Here's something you might not want to think about, but probably should. New studies found that dozens of so-called forever chemicals, also known by that acronym PFAS, are showing up in the drinking water around Montreal. It shows that the St. Lawrence River has the highest amount of these chemicals. You can get a load of this. Water treatment doesn't eliminate them. Let's talk more about forever chemicals with Polytechnique professor Sarah Dorner, a co-author of this new study. Professor Dorner, Sarah, welcome back to the program. Great to talk to you.
Yeah, thanks for the invitation.
So first things first, the PFAS, I don't know how you, what's the way to...
I'll say PFAS.
PFAS, there you go. Forever chemicals, what exactly are they?
Yeah, so these are chemicals where there are fluorine carbon bonds that are very, very stable. And so these bonds can be very useful. These compounds can be very useful. So stability, if you're fighting fire, like firefighting foam, you don't want these things to break down. So these are very useful chemicals for their purposes, but stable also means persistent and doesn't degrade fast in the environment. Also, these compounds are used in non-stick cookware, for example, or things that prevent grease from passing through packaging for foods. So these properties that they have also mean that they're not sticky, so they don't stick to particles. And a lot of our conventional treatment is based on removing pathogens and particles. So you have particles that stick together and you settle out and you filter them. Well, these aren't as easily filtered because they're not sticky in the same way. So they pass through drinking water treatment.
So let me ask you, I mean, you mentioned some of the products that have these forever chemicals in them, but how are they getting into the St. Lawrence at such a high number? Where is it coming from? Is it coming from the food packaging? Where's it coming from?
Yeah, so there's really a multitude of sources. So it's coming from upstream. And when we think of the St. Lawrence, this is a big river. It's a lot of flow. I'll also point out that Health Canada has new objectives and we do meet all of the drinking water treatment plants do meet those objectives. So that's a good thing. What we're talking about here is that we don't really want this in our drinking water. So that's the question. What do we do about this? We don't want it in our water. So where is it coming from? So because these are highly persistent compounds, they can come from pretty far upstream. So everything upstream, and we're talking about the Great Lakes Basin, all of the industrial areas where they're being produced, any firefighting foam, that when it's applied directly to the environment, there's runoff, it ends up in the water. Pesticides, it's also on a lot of clothing and pharmaceuticals. So if you wash clothes that are treated with PFAS, that can end up in the wastewater. So there's really a large number of sources, which also means we have other ways that we're being exposed to these compounds. So it's not just in drinking water, it's also in food. But we don't want it. We don't really want it in drinking water because if it's there, it's very difficult and expensive. There are ways to reduce it in drinking water treatment, not in conventional so much, but it adds a cost, and nobody likes paying taxes, right?
And I guess I should get to why we should want this stuff removed. What do we know about the impact if these PFAS, these forever chemicals, are in our food or in our water? What's the impact to human health?
Yeah, so there are studies. So some of these compounds have been around for a while. There have been some that have been replaced. So those that were identified as more toxic, they have been replaced with other shorter chain PFAS, so smaller chains of carbons, but those that actually pass through drinking water more easily. So there are health effects. I'm more on the water environment side, but yeah, that's why. Essentially, because there have been demonstrated health effects with immune systems and other concerns. That's why there's an interest in this. It's not just that it's there.
So what do we do about it? Obviously, we could try and filter it out of the water. You've mentioned some of the difficulties. Maybe there's newer technologies we can use. But is it a better approach to just get rid of them before they get into the water, I imagine?
That would be ideal. We do know that there are hot spots. So, for example, I mentioned firefighting foam. Airports are often point sources, like the runoff from airport areas. So if you could potentially put in bioretention cells with sorptive material, so there are ways of doing it. So it's really about exploring where, if we can identify where these hot spots are, perhaps we can put in treatment. In the U.S., there are Superfund sites. So we're kind of watching what's going on in the U.S. because this is a case where we are really downstream of what's going on everywhere. So there are known contaminated sites. It would be good to see those sites treated. But also there are a lot of uses of PFAS that perhaps are just not necessary. So we can just eliminate. That would be the ideal thing. So if there is no need for a particular substance, then those could potentially be regulated because we don't need those.
What would be an example of the unnecessary that we could get rid of?
Yeah, I'd say the harder ones are the firefighting foam.
Yeah.
Pesticides is also tricky because pesticides can also contribute. But cosmetics, those kinds of things. So there are ski wax.
Oh,
there are alternatives.
Yeah.
So where there are alternatives, that's really the best thing to do. Food packaging, given that that's an important point of exposure, making choices as consumers. Microwave popcorn, I know that there has been progress in replacing certain substances, but you can make popcorn on the stovetop.
Geez, so what's wrong with the microwave popcorn? Fill me in here.
It's delicious, isn't it?
Yeah.
So if you want to reduce your exposure to PFAS, so that's one of the things in food packaging. It's to check to choose options that are not. Perhaps in branding and such, there can be options where it says not treated with PFAS.
Yeah.
But otherwise, if you just want to be sure, you can make your popcorn.
Is there a link with plastic and PFAS?
That's an interesting one. Microplastics is another question. Oftentimes, we have similar sources in the environment, but they are distinct. They are distinct compounds and concerns and potentially different sources. So
Gotcha.
the microplastics are particles, so they don't have quite the same challenges for elimination because our drinking water treatment systems can be optimized for removing particles. So it's a bit easier. These are really slippery
substances.
Yes,
Sarah, listen, got to leave it there. I want to thank you for coming on.
Okay, thanks for the invitation.
That's Sarah Dorner, professor at Polytechnique, Department of Civil, Geological, and Mining Engineering, a drinking water expert.